Today I have Joe Dluzen. He's a friend and co-author. He's a former consultant, now a senior solutions engineer at C&H Industrial. He's been on before. I'm happy to have him on again. He was my mentor and saved me from many technological tragedies by being totally dogged about chasing down problems that would have made me pull my hair out. He also taught me a great deal about distributed computing and containers, which is what we'll be discussing today. Hi, Joe. How are you?
Hey, Jesse, I'm doing good.
Tell me about distributed computing and containers. Tell me everything you know. I'll just sit here quiet.
Everything I know. Oh boy, there's certainly lots to go over. So, kind of just pick
Let's
a.
start with a definition of what we mean by distributed computing.
All right. Well, let's see. The actual word there, distributed computing, is fairly self-explanatory. With computational systems, you can't all have all the computation all in one system. So, you need to distribute it out or fan it out to other systems to do either their own thing or a specialized thing. Um, that's I'd say the high level.
Well, let's be slightly more concrete. First of all, there's computing on my local machine. That's one possibility, where everything is on my machine. The other possibility is I move everything that's on my machine up to, let's say, Azure. That's still not distributed, right?
Not necessarily right. Azure is part of what we think of when you push things to the cloud, right? It's a one cloud provider, and you can have your own individual instances on individual VMs on there, for example. But that doesn't necessarily mean it's distributed computing. Um, I guess to me, when people say distributed computing, it's more along the lines of horizontal scaling. It's kind of the first thing that comes to mind, where you have many individual instances of the same software in general doing exactly the same thing, serving many customers, for example.
Okay. So let me be clear. So we're talking about the same full application, but it's running on multiple places. That's what you mean by horizontal.
Yeah, for horizontal scaling in this case, yeah, that sounds like right.
Okay. So what would vertical scaling be?
So vertical scaling is essentially the opposite. Where in horizontal scaling, you have multiple instances or VMs of the same machine with the CPU and memory and computational resources usually being the same, although not necessarily. Um, Vertical scaling is essentially the opposite. So a single VM could be scaled upwards. It is the kind of the term for that, and that could be add more CPUs to that VM. It could be adding additional memory. Essentially, a single VM getting bigger, as in physically bigger, physically more resources, rather than little tiny horizontally scaled outward VMs.
Okay. So two things come to mind. One is taking that program and breaking it into pieces and distributing those pieces on different computers. And the other is the idea of containers.
Mhm.
And those are different things.
They are, yeah.
So let's take them one at a time, which is the idea of breaking things up into what word do I want? Modules?
Yeah, we could go with that. I mean, there's a number of related words that are similar that can change depending on the use case, um, like Docker images, for example, containers. Um,
But I thought pardon my ignorance here, but I thought a container had the idea of the entire VM inside one object and the entire program, so to speak, is inside that one container as opposed to having pieces that are chunked out.
oh, well, I think in the traditional sense, when we talk about containers and Docker specifically, I know there's other kind of related non-Docker container containers, but traditionally in like a Docker container, it's generally referred to as a lightweight VM, and whether that's an app description is kind of a fuzzy subject, so we'll just kind of leave that alone for a minute. But essentially, yeah, it's a environment that your app or multiple apps can run in that is isolated from the host system. Taking Linux for example here, the code itself is runs on the native CPU. It can access physical resources on the VM, for example, for like a graphics card, GPU, compute object, device, physical device, something like that. It in general has full networking access. You can restrict things like that. You can only allocate certain amount of CPUs to it. A lot of different options you have to either have that single running container be on the VM and take up almost 100% of its resources, or you could have multiple containers running on a single VM and split up and share resources as appropriate.
Would that container have a piece of my program or my entire program? Or is that, do they both work?
Well, I would say they could both work. You could essentially Dockerize a single application and deploy it to any kind of system like that that has Docker in general. Depending, architecture, CPU architecture dependent, of course, and if it is a individual microservice, for example, then yeah, you could take that and deploy that just as you would with the larger app, and that individual Azure resource, for example, would could handle its own scaling. It could handle its own CPU allocation, memory allocation, and then that could be made up of a system of more pieces. Other microservices or databases or blob containers, things like that.
So let's talk about what the advantages of putting things into a container rather than just having them run on the operating system.
Yeah, let's see. So when you develop an application, there's many dependencies that are usually associated with your application. Your app needs JSON processing. It needs a specific database protocol, libraries, things like that, and keeping all of those in sync with the application is can be quite a chore. Some languages and frameworks are more difficult than others, but we'll leave that aside for now. Um, so the container essentially packages up everything your app needs, file system wise, including the dependencies, your any kind of assets you need, images, um, binary files, whatever you want to put in a container that's on like a file system, that can be packaged along with your app, and then that allows it to be downloaded as a singular object on the host machine and started up and executed.
Okay, let's talk concretely. If I have an application and I want to put it in container, what am I doing? Am I bringing up a GUI that looks like a box and dragging things in? Am I doing that in YAML? How am I actually making that work?
So when we take a look at what kind of Docker provides out of the box, the I guess default artifact we'll say is the Docker file, and that's exactly how it's named, Docker file, all one word, and that is a description of how the container is built. You can execute commands in it. You can copy files from the host system to the container image itself. You can add environment variables, um, a variety of things like that. And then when you actually build the Docker image, it takes that file and executes it line by line to build up many different layers of your application, and then finally outputs the very last layer, which is a kind of it's tagged with a string that is like the kind of top level Docker image that you would normally download.
And that image presents itself because so far we've been on my local machine, right? We've been doing everything that you just named on my local machine.
We can, yeah. You can run it on your local machine, and then you can run this in CI/CD, for example.
Mm-hmm.
You can build the application wherever you want. In general, it's usually in a CI/CD pipeline, and in general, from what I've seen, it's usually on the architecture specific CPU as well.
Right. And then once that Docker container exists as part of the CI/CD pipeline, it's going to automatically be distributed up into the cloud.
Um, Sort of, yes. To get that Docker image over to your compute resources, there are container registries, and you can upload your image to the container registry. In which case, then the compute resources like Azure Function and so on would then pull that Docker image down from that container registry and locally cache it and then execute that. Um, there's many different services that provide that. Some are free. Docker Hub is a good one. You got many public Docker images there. There's private container registries. That's its own service in Azure itself. So your CI/CD pipeline could publish the Docker image over to your private container registry in Azure, and then your compute resource like Azure Function could download that image and start it running.
And let's talk about the role of Kubernetes in that.
So yeah, Kubernetes is a container orchestration system. It allows the execution of the Docker images. There's a whole ecosystem of management and tools along with it. Um, it kind of manages its own system of kind of fan out, scale in when user requests are go up and down and fluctuate normally. Spin up additional images and copies of the image. There is smooth rollout of new versions of the Docker image, for example. So a lot of things like that.
Okay, I'm at the moment looking for work, and I've looked at probably 200 or 300 job listings. And if there are 300 of them, 298 of them say experience with distributed computing. It doesn't sound like there's anything very difficult or complex or sizable to it the way we've described it so far. So, what's the issue that that's being called out all the time? I love doing these interviews as if I have no clue.
Let's see. Yeah. So, yeah, that could mean a number of different things. Distributed computing in general, when it's on a job posting like that. To me, that would be something like what we've kind of described so far. Like the Docker containers and images are a piece of this distributed computing. Having knowledge of how to make them, how to push them up to the container registry, how to actually have resources that pull and scale out is all part of the system. And to me, that's what kind of those words would mean to me if I saw that on a job posting.
Right. And how different you may or may not have experience with AWS. Do you have a sense of how different it is to do this in Azure versus AWS? Is this a parallel experience, or I mean, is it a matter just of syntax, or are there semantic differences?
I would suspect I haven't looked in AWS in a while, so but the actual underlying technologies are fairly ubiquitous. So
Right.
I would expect it to be similar. If it was not similar, I would be pretty surprised. Yeah.
Right. Especially because, I mean, there may be things that are unique to either one, but Docker has to be supported on both, right? So it has to have
Yeah.
a somewhat universal interface, I would think. So, what else should I know about distributed computing, or is this going to be the world's shortest podcast?
Yeah. Well, we could continue to talk about some other advantages of Docker images.
Please.
Let's see. So I think the most one of the most notable ones for me was a number of jobs ago. We were working in a large, very large corporation, and the company was distributing their developer tools as a Docker image, and so that made it really easy for someone new to come into the environment, spin up this Docker image on their local machine, and now they have all of the libraries, the tooling, all of the assets needed to start doing their work right away. Um, what we didn't originally touch on was the layers in the Docker image are essentially file system layers. They actually layer on top of each other, one after another, building up a file structure that eventually ends up in the what looks like a completed picture of your app and dependencies. So you could continue to add on to other Docker images, for example. Um, I've been doing that personally with, I think there was AMD provided a low level um, AI compute Docker image that you're able to add your own models and scripts and code to, and so they would essentially provide you with out of the box, well known, well tested libraries that you could build your own apps on. So taking that a step further, um, with the tooling aspect on the Docker images, you can have multi-stage, multi-build uh, Docker Docker files. So instead of just a single Docker file building your app and then having your app be built on on the host system, you can set it up. And I think I just checked this actually with the Visual Studio out of the box Docker file. Essentially, lets you use their pre-built Docker image SDK, .NET SDK, sorry, and then your app will be built inside a container using the .NET SDK as like a base, and then um, your app will then be copied into the final Docker image at the end of the build process.
Are
So
you saying that to do that, all I need is Visual Studio, or I need Visual Studio plus I need some sort of desktop Docker app?
there is Docker Desktop, and that does provide like a UI
Hmm.
to manage the Docker images. I think last time I checked, it uses the Windows subsystem for Linux under the hood. Um, so I generally just use command line for that for WSL, and then Visual Studio can interact with WSL and start off the Docker image build process and so on.
Okay. If someone wanted to get started and wanted to build a simple application,
Mhm.
maybe with one dependency, just to get their hands on this, get. I was going to say their hands wet. I think the expression is to get their feet wet. In any case, um, so they start with Visual Studio. They get the Docker desktop app, and what do? They open up a console app and make a hello world, or what's the first thing that they need to do to if they know that they want to make a Docker app?
Yeah, I think Visual Studio provides that right out of the box pretty nicely. If I remember, the console app wizard has a checkbox actually for containerization or Docker file or something like that. And yeah, it sets up the multi-stage build process right away as out of the box. So it'll use a pre-built .NET SDK right from Microsoft to build your app, and then it will use a smaller runtime .NET Docker image to actually put your compiled app files onto.
Too easy.
It's pretty nice, yeah, out of the box. Yeah.
We're seeing Docker and containers used a lot with building AI applications. And I think that begs the question then of whether there's a difference in how containerization is used in that kind of application as opposed to in a more conventional application, or is it really agnostic as to what kind of application is running inside the container?
It's pretty agnostic, yeah. It's not necessarily a low level core feature like Docker itself, but it does require operating system support. But what you can do with that, yeah, is sky's almost a limit on that. With it being file system layered like that, you can have individual files. You run applications. You can have, yeah, the actual models themselves can be in there as well. There are another kind of flavor of Docker containers that they're called sidecars, and essentially that's a pretty apt description of it. So you have your own main application running, for example, and then a sidecar app, a sidecar Docker container running right next to it to provide some type of service. I believe, if I'm not mistaken, that the Azure authentication provided by the resource itself for EasyAuth, I think that runs in the sidecar in Azure.
And those are built independently of each other, the main part and the sidecar built
In
later and
general,
then added in?
in general, yeah, they're usually separate. They can be completely separate images themselves. They don't necessarily have to share a root Docker image, for example, but they can. Yeah.
And why is it that that .NET containers are run on Linux boxes?
Well, I think in general, it's for a long time now, since .NET, .NET Core One, I think provided Linux support out of the box, something like that. And then, of course, there was the amazing Mono project before that ran .NET Framework on Linux, and that's still around today and on Android phones and iOS and things like that. So, but yeah, as far as like running .NET on Linux, it's been a very large target of Microsoft for quite a while now, and it's first class citizen for all the different services on in Azure, and yeah, it is absolutely my default for running services is .NET on Azure
On Azure on Linux.
on Linux. Yeah,
Well, that was a really good introduction and maybe beyond an introduction to distributed computing and to where containers fit in. I think that this was really helpful. It demystified a lot of what's involved, and I thank you very much. It was very useful.
great. Glad to hear it.
You have a good day, and we'll have you back soon.
Look forward to it. Thanks, Jesse.